Hi guys, and welcome to our next lesson in our circle topic. Today we are going to be discussing arc length. So your aim for today is to be able to use your arc length formula. So what is an arc? An arc is a fraction of the circumference of a circle. So here you can see we've got a pink circle and I want to look at the black sector, which is A to B, and the arc is that curved bit going from A round to B here, like so. We call the black section the minor arc, and the pink section would then be our major arc. So minor means small and major means big. Our circumference then, we should know from last week's lesson, was that circumference is equal to pi times by your diameter. Well, our arc length is just a fraction of that circumference. So we take our pi times by d, and then we are going to multiply it by the fraction that we want. If we are wanting that minor arc between A and B, then we would take our angle x out of the full circle, which is 360. So the fraction we want would be our angle out of the full 360. And this is our important formula for today's lesson. You're going to find that we're using that a lot. Example number 1 then, we need to calculate the length of our arc correct to 1 decimal place. So I'm going to shorten arc length to AL for today's lesson, and our formula was pi d times by x over 360. So let's think about this. If we look at the sector there, really if I extended my circle round, it would look, something better than that hopefully. This would be our centre right here. So we can see if we're going from the centre out to one edge, 9 is our radius. We don't want the radius though, we want our diameter. Our diameter is 2 lots of our radius, so it's going to be 9 times by 2 to give us 18 centimetres. So what I'm going to have is pi times by 18. X then is just my angle, so multiplied by 30 out of the full 360. And what I would do when I'm putting this into my calculator is pi times by 18 times by 30, hit my equals, and then divide by 360, and that should give me 4.712. We have been asked to round it to 1 decimal place, so what we are going to do is look at the first number after my decimal point, which is 7. The one after that is 1, so that tells us to stay the same, so it's going to be 4.7 centimetres as our answer. For example 2 then, we are going to do the same thing. So this time I would like you to pause the video, try it yourself, and then play the video to see if you did it correctly. Okay, hopefully we gave that a go ourselves. So arc length is equal to pi times by diameter times by x out of 360. So this time my diameter is going to be 2 lots of 12, so our diameter is 24. We are then going to multiply it by the angle, so it is 72 out of 360. And again I'm doing pi times by 24 times by 72, hitting equals and going straight to divide by 360 to give us 15.079. Again, it was just 1 decimal place, so my answer here is going to be 15.1 centimetres. Our arc length is just a length, so our units just need to match whatever our radius or diameter has been given in. So in our case, it's centimetres. Example number 3, we have been asked to calculate the perimeter of the arc correct to 2 significant figures. So remember, your perimeter is the total distance around the outside of the shape. So for us, that's going to be our arc length plus the 10 centimetres and the 10 centimetres on the other side of our arc there. So I'm going to start by finding my arc length, just like we have been doing. So pi times by the diameter times by x out of 360. This time my diameter is going to be 20 centimetres because our radius here is 10. So times by 20 36 degrees out of 360. And that should give us 6.283. We've been asked for two significant figures, but I'm just going to leave it just now until I get to the end of my question. Sometimes it can affect your answer if we round too early, so I'm just going to leave it as 6.283 ... Our perimeter then is going to be our arc length plus the 10 centimetres plus the 10 centimetres. So that is our 6.283 plus 10 plus 10. I'm actually just going to label this as perimeter. So really what we're doing is we're adding 20 on there to get 26.283. So we wanted two significant figures for our final answer. So my two highest place values are the 2 and the 6. This 2 here is telling us to stay the same. So we are going to want to stay as 26 centimetres as our final answer there. We don't want anything after a decimal point because then they will count as significant figures. For example 4, we are going to calculate the major arc to 1 decimal place. So this is why it's important to read the question carefully, because they have specified the major arc, and for us that is this side here. So our major arc length is still the same formula, so pi times by the diameter times by your angle out of 360. Our radius here is 15, so our diameter is going to be double that to give us 30. So pi times by 30. But this time the angle that we want is the angle related to the major arc, and we don't know what that is. We know what the minor arc is, it's 80. But we should know, as we've already mentioned, that our 360 degrees is our full circle. So in order to get our major arc angle, all we need to do is our 360, take away the 80 to give us 280 degrees. So this angle here is 280 for our major arc. So we are going to do times by 280 divided by 360. And that gives us 73.303. We wanted it to 1 decimal place, so that is just 73.3 centimetres there for our major arc length. For example number 5, we have been told that our arc length xy is 25.1 centimetres. So what that's meaning is that our curved edge here is the 25.1 centimetres, and we've been asked to calculate what our radius is. So we don't have a formula to find the radius from our arc length, but if we start with our arc length formula, we know that it is pi times by the diameter times by the angle out of 360. And what I'm going to do is replace everything in this formula with what I do know. So starting with arc length, we do know that is our 25.1. Pi is just pi, we know what that is, either using 3.14 or using the button in our calculator. We don't know the diameter, but we know that our diameter and the radius are linked, so we're just going to leave it as our diameter just now. Our angle then is 55 and it's still out of 360. To tackle this question, what I want to do is get everything onto the one side and have the letter D by itself. So the first thing I'm going to do is bring up my 360, and the opposite of divide is multiply. So what we can do is our 25.1 times by 360, and that gives us 9,036 is equal to pi times with the diameter times by 55. Then what we are going to do is, doesn't matter what order, but we can go over and divide by pi. Is going to give us 2,876.248. Don't need to write the whole thing out. And then what we are going to do is take our 55 over and divide by it. And that gives us 52.295 is equal to the diameter. And what we should know is that our radius is worth half of the diameter. So all we need to do is our diameter divided by 2. So that's the 52.295 divided by 2. So half of that is going to give us 26.147. It was to 1 decimal place, so my final answer is going to be 26.1 centimetres for our radius. Our final example, so well done for sticking with me if you've got this far. An ice cream shop has made a new logo for their store. We need to calculate the perimeter of the design. So what we want is our arc length plus the 15 plus the other 15 to get that pink line round the outside of the design. So what we are starting with then is our arc length, and that is going to be pi times by the diameter times by x over 360. So pi times by 18, because our radius was 9, so the diameter is going to be 18 centimetres. Our angle, because it is the major arc, is this angle round here, which is our 220. And then it's a case of plugging this into our calculator. So that's going to give us 34.557. Our full perimeter though is your 34.557 plus 15 plus 50, because that's us going round the full outside of that circle, the dark pink line there. So that's going to give us a 64.557, and it hasn't asked for anything, but I'm just going to round it to 1 decimal place to give us 64.6 centimetres for the perimeter of the design. Well done guys, that is you at the end of today's lesson. I've not split it into sections this time. Hopefully we get through the work much quicker today than we have our last couple of lessons. You can see here I've got 6 basic calculating the arc length to 1 decimal place. Be careful with parts E and F, they're a wee bit trickier. Question 2 is calculating the minor arc. So remember, minor means the smaller section. So you need to decide, have you been given the information for the bigger or the smaller section? Question 3 is asking you to calculate the major arc length of the same circles there. So that is your bigger section this time. And then lastly, we've got some extension questions. So these are a lot trickier than the previous 3 questions. I still expect you to try these and give this your best go. If there are any problems, I'm always available on our Teams chat if you need a wee hand. Best of luck, and I will see you in the next video.